This content is AI generated for informational purposes only and should not be directly used for clinical decision-making.
Hello and welcome back to the Neurosurgery Hub podcast. I'm Dr. Aris, a senior attending here, and today we're diving into the cutting edge of intraoperative technology.
And I'm Dr. Ilara. Today we're looking at a fascinating new study from the journal Surgical Oncology, published in 2026, titled Towards Real-Time AI-Augmented Fluorescence-Guided Surgery, Evidence and Translational Readiness Across Neurosurgical, Gynaecological, and Thoracic Oncology.
This is a timely narrative review, Ilara. For those of us in the OR, fluorescence-guided surgery, or FGS, has become a staple for enhancing intraoperative visualization of tumor tissue and lymphatic drainage. But as any resident or attending knows, it's far from perfect.
Exactly. The paper highlights that while FGS is increasingly used across oncological specialties, its clinical impact is actually limited by several factors. We're talking about heterogeneous tracer uptake, variable signal intensity, and a heavy reliance on subjective visual interpretation.
That subjective part is the real killer. It leads to significant interoperator variability. One surgeon sees a faint glow as a margin, another sees it as background noise. That uncertainty at tumor margins can lead to residual disease or, conversely, over-resection.
This is where the study introduces the role of artificial intelligence. The researchers synthesized evidence published between January 2000 and December 2025. They wanted to see if AI could address these limitations by providing real-time, AI-enhanced interpretation of that intraoperative fluorescence.
And neuro-oncology seems to be leading the charge here.
It is. In neuro-oncology, the review found that early clinical and preclinical studies have already directly evaluated real-time AI-enhanced interpretation. They specifically looked at the quantitative analysis of 5-aminolidelic acid, our standard 5-ALA, and hyperspectral imaging.
That's a major shift, moving from "I think I see a pink hue" to a quantitative analysis. The paper describes this as proof of concept evidence that AI can augment margin detection beyond that subjective visual assessment we just discussed.
It's about technical maturity. In our field, AI is being used to interpret the signal itself as it happens. Interestingly, the paper contrasts our progress with gynecological and thoracic oncology. Even though fluorescence imaging is clinically established in those fields, they currently lack validated studies where AI directly interprets the intraoperative fluorescence signals.
That's an interesting distinction. If they aren't using AI for the fluorescent signal, where are they using it?
The study notes that in those specialties, AI development has progressed primarily in adjacent domains. We're talking about radiomics, digital pathology, risk stratification, surgical planning, and intraoperative computer vision. They have the technical maturity in those areas, but there is a clear translational gap when it comes to integrating that AI into fluorescence-guided decision-making.
So for the residents listening, the takeaway is that while other fields use AI for the before and after, like planning and pathology, neurosurgery is pioneering the during. We are looking at real-time integration.
Precisely. The review concludes that the available evidence supports the feasibility of real-time AI-enhanced fluorescence interpretation in our domain. However, the authors emphasize that for the broader surgical community, there's a need for targeted research to integrate existing AI capabilities into intraoperative FGS to solve those issues of inconsistent nodal assessment and margin uncertainty.
It really highlights that we are moving towards an era of AI-augmented surgery. It's not just about seeing the fluorescence, it's about having a digital partner that can quantify that signal to reduce the interoperator variability the paper warns about.
It definitely makes the case that the future of the neurosurgical OR involves bridging that gap between subjective visualization and objective AI-driven data.
A compelling read for anyone interested in the future of surgical precision. That's all the time we have for today. Thank you, Dr. Ilara.
Thank you, Dr. Aris.
And to our listeners, stay sharp and keep learning. We'll see you in the next episode of the Neurosurgery Hub podcast.